So let's start from the first test paper here. So the first question is here, for example, we have some kind of short answers. If E multiply this matrix here is equal to this one, then what is the value of E? So, okay, let me download this one.
পুরা পুরা গন্ধ আসে এই ফ্যানটা চালাবে
Actually, I don't have any preparation today. Okay, so here we can see like we have 4 here, right? We can see that this is our second row. This is our second row. Okay. So this one here, this is our second row, and we can see that we have our second row here, right? A21, A22, and A23, right? And then we have multiplied -4. We have multiplied 4 with the second row. Okay. And the row operation here, that is going to be R1 minus 4 into R2. Okay. So this is the row operation that our teacher that here it is done. So that's why the answer will be okay. That's why we can see that. Okay. So we can see that this is our row operation. So at the first one here, the answer will be this one. Okay, R1 minus 4 into R2. But the value E, I think it will be. So our teacher was too fast. I couldn't write down the answer, the correct answer. I'm not sure where is her note. Okay, so I think the answer will be R1 minus 4 into R2. I think so, but I'm not sure. Okay, because I maybe I skipped this part. Our teacher was too fast. That's why I couldn't write down this part. So guys, can you understand like how this row operation was done?
Yeah.
Okay. So basically, we can, if we look here, we can see that the changes these are on the second row. You see here, second row, and the second row is multiplied with 4, right? And then this is our row operation. So that's why I think the answer will be this one. But I'm not sure that which things we need to write down here, but maybe this one. Okay. Yeah. So let's continue. Number 2, we have Bx. It's the matrix of x by r, and A, it is a matrix of x by r by y. So there are two matrices. If B multiply A can be defined, then the size of BA is okay. So the theory is we have two matrices here, right? And we have to look at the column of the first row and the row of the column of the first matrix and the row of the second matrix. This two needs to be same. Okay. In order to multiply them, these two things needs to be same. I mean the column of the first row, first matrix, and the row of the second matrix. Okay, this two needs to be same if we want to multiply a matrix, and the size will be the row of the first matrix and the column of the second matrix. Okay, that means let me change the color. So the size will be x by y. Okay, so it will be x by y. Guys, can you understand? Actually, there is a lot of noise around me. That's why I'm getting distracted. So, anyways, let me explain again. Okay. So we have two matrices here, right? The first one is x by r, and the second one is r by y. So uh, to multiply a matrix, to multiply two matrix, we need to make sure that the the column of the first matrix is equal to the row of the second matrix. Okay, so you can see here we have r equal to r, right? And then you need to look up. Then we are going to find the size. So the size will be x by r, or the row of the first matrix and the column of the second matrix. Okay, the the row of the
Got
first
it.
matrix and the column of the second matrix. Okay, the third one. Okay, let's see the third one. So here we have to add two matrices, right? Let's see the question. So we need to find a plus b. So to find to find the sum of two matrices, we need to add the corresponding entries. Okay. For example, this is this is one. This is one. This is the first row and the first column. Okay. So it will be a11, right? And this one, it will be also a11 because it is situated at the it is situated at the first row and also at the first column. So we need to add these two entries and write down the answer here. So 1 multiply 1, that will be 2, right? Okay. And then down here, this entries and this entry. So 1 plus 2, it will be 3. Okay. So this way we calculate all other entries. So this one will be our answer. Okay. I hope you guys can understand. Like, it is very simple.
There is no any other formula.
No. There is nothing else. You just need to add the corresponding entries uh, from A and B. Okay. That's all. Okay. So let's see how we can find inverse matrix. Question number 3. So we have a matrix of 4, 9, 3, and 7. So now we need to find the inverse matrix. Okay, let me use my mouse pad. Yeah. Okay. So we have 4, 9, 3, and 7. So here is the process. Okay. Inverse matrix. So you see, this is a 2 by 2 matrix, right? 2 by 2 matrix.
Yeah.
So to find the inverse matrix of 2 by 2 matrix, there is very little formula. So we just need to exchange the value of a11 and a22. Okay, that means we need to change these values. So okay, so we take 4 here, and we take 7 here. Okay. Mouse is having some problem. So we exchange these two values, and then then we have to multiply minus here and also multiply minus here. Okay, that means the other corner. So
Mm.
we exchange the first corner from left to right, and then we multiply with the minus, with the minus with the second corner. Okay, so the result will be, yeah, the result will be here. Okay. Oh yeah, so
More
yeah, I mean the
right.
this was the question and the answer will be here. Okay, sorry, Jem.
I didn't get why we multiply the minus.
Okay, let me show you again. Actually, I did a mistake here. That is, our our matrix was 4937, right? So okay, so you can see here this is our matrix 4937. So we exchange the corner. We exchange the first corner. So here you see 7 is here and 4 is here, and then we multiply. Then we multiply with a minus sign with the second corner, right? So -9 and -3. Okay, -9 and -3.
Why we do this?
Because this is the formula. Okay, for 2 by 2 matrix.
Okay.
For
It's
2 by
just
2 matrix, this is the formula. But if it is a 3 by 3 matrix, then the formula is something else. Okay, I'll show you. I'll show you. Okay, no problem. So let's have a look at part 2. Topu, can you understand
Bye.
Topu? হ্যাঁ ভাই বুঝতে পারছো?
Yes, bro.
বুঝতে পারছো ভাই?
I got it.
Already?
বুঝছি।
Okay, okay, ঠিক আছে.
3 নম্বরে
Okay, so let's have a look. Sorry ভাই, 3 নাম্বার বুঝো নাই?
না 3 নম্বরে বুঝতে পারি না। ওইটা আমার নেটওয়ার্ক চলে গেছিল তো কানেক্ট করতে
আচ্ছা।
করতে আর খেয়াল করতে পারি নাই।
Okay, let me explain this number 3 again. Okay, so we just need to add, so we are adding two matrix, right? So we just need to add the corresponding entries. Okay, for example, this is A11, this one is A11, right? And this one is A11. So I mean we just need to add the corresponding entries. So 1 plus 1, that will be 2, right? So here it is 2, and then 1 plus 2, that will be 3, right? So 3. So we are just adding corresponding entries. -1 plus 2, that will be 1. Okay, and then here on plus
বুঝতে পারছি।
-1,
বুঝতে
that
পারছি।
will be 0.
ওকে
Okay.
বুঝতে পারছি।
So let's continue to part 2. So part 2 we have, okay, so choice of the correct answer should be indicated by A, B, C, D. Okay, so we just need to choose the correct answer. Okay, which of the following matrix is in reduced row echelon form? Okay, so you need to look at some kind of things. Like the first one will be all the entries. If it is 0, it must be at the end. Okay, if all the entries of a single row is 0, it must be at the end. Okay, okay.
Okay.
And the second condition is all the entries below the pivot point and above the pivot point, they must be 0. Okay, okay, so let's remind these two things. If there is a 0, I mean that if there is a row, all the elements containing 0, it must be at the end. And if and we need to look at the pivot point. Okay, so what is the pivot point? So pivot point is the first non-zero entry of a column. For example, this of a row, so for example, this row, we have 1, 0 and 1, right? So the first non-zero entry is 1. That's why this one is our pivot point. Okay, and then on the second matrix, on the second row, there is all the entry they containing 0, right? but
Yeah.
but
We,
our condition was this needed to be sit at the last, right, at the last row. So we cannot take this answer because it is not a RREF or reduced row echelon form, okay, because it breaks our condition. So let's see the second one. So here this is our pivot point, and all the entries below this pivot point, it is 0, right? But okay, so and on the above we have nothing, so we can just say that all the entries above is also 0, okay. And the second pivot point is here, right? Because we don't have any entries here, that's why on the second row here, the first non-zero entry is here, right? 1. So we need to see if all the entries above this pivot point and below this pivot point is 0 or not. So you can see that below this pivot point, the second pivot point here is on, right? So this is also not RREF. Guys, get it?
so what's a pivot point?
Yeah, pivot point. So pivot point means the first non-zero entry of a row.
Please let me write it.
Yeah,
Can you
sure,
say
sure.
that again?
Okay. So on the second matrix, this is our first row, right? And the first non-zero entry, that means it will not be 0. So the
Yes,
first non-zero
10.
entry is 1, right?
Thank you.
Okay. And we need to see all the entries below this pivot point and above this pivot point must be 0, right? This was our condition. So so here the first one is right. All the entries below this pivot point is 0, and also above this pivot point is also 0. But for the second pivot point, but on the second row, oh sorry, where is that? Okay, okay. But on the second row, our pivot point is here, right? Because the first, yeah, because the first two entries, they are 0 on the second row. On the second row, the first two entries are 0. That means our pivot point is here. But all the entries below this pivot point is not 0. You can see here we have 1. So that's why this is not RREF, okay?
Okay.
So let's see the third one. And also the pivot point, it must be only 1, okay? Like this way, 1, 1, 1, okay? And all the entries above and below this pivot point must be 0.
Should be.
Yeah, so
Must be.
yeah, so pivot point also must be 1, okay? That means that is called RREF, or reduced row
Not.
echelon form. Yeah. So let's see here. The first pivot point is here, and all the entries below this pivot point is also 0. The second pivot point is here, but it is not 1, right? It is 2. That means it is also not RREF. Okay. And the fourth one here, this is our first pivot point, and all the entries below this pivot point is 0. And on the second row, our pivot point is here, and all the entries above and below this pivot point, this is also 0, right? We don't consider this 4, right? We don't consider this 4 because this 4 is not our pivot point. So that's why this is RREF, okay?
It's now more clear.
Okay. Is it clear, James?
Yeah, yeah. Thank you
Okay.
very much.
Yeah, yeah. So let me remind you the formulas. The first one was, if there is all the entries in a row, if they are all 0, then it must be at the end. Okay. The first condition. The second condition was like all the entries below and above the main pivot point, all the entries below and above the pivot point, it needs to be 0. And the third condition was all the pivot point, there needs to be one, right?
Yeah.
Okay. So this is called RREF, or reduced row echelon form. And this way we find out which matrix is RREF and which matrix is RREF, which matrix is not RREF. Okay.
Okay, thanks.
So Topu, can you understand?
Yes, bro.
Okay. So I'll give some link after the class so that you can see those videos. Like videos from Khan Academy, they are very good, and I also learned from them. Okay. And this math we had in our these types of math we had in our high school. Okay, I mean grade 11 and 12. So that's why we have some kind of experience solving these types of problem earlier. But in our language, not in English. Okay.
We didn't have it in our school in the last grade, so I am a
Oh.
bit confused.
Yeah, I know. Some of them are from not from science background. That's why I think this math is kind of difficult for them, right? Okay. So let's
It's
see.
very difficult from that.
No, these are very simple. Like today, I have no preparation. I have zero preparation, and I was super tired. Like 20 minutes ago, I went to sleep. Then suddenly, I woke up and I just remember like I had a class with you guys. Okay, so I was that much tired, and all the people around me is they're sleeping, and so
Better because
yeah,
you'll learn from the class of 11.
yes. So you could listen the cry, the I mean the screaming of a baby like beside me. He's sleeping. So yeah. Anyways, let's continue. Which is the linear equation in x, y, and z? So linear equation. Number C. Okay. So the formula is very simple, like variables that contains degree with 1. They are linear, okay? Variables means x, y, z. Okay? So variables that contain degree with 1. Degree means power. For example here, okay. So here the degree of x is 1, right? Here degree of y is also 1, and degree of z is also 1. Here degree of x is 2. Here degree of y is -1. So this way, this is called degree or power. So for a linear system, the variable that must contain degree with 1, okay? And the variable with no functional term. That means they are not multiplied. That means there is no xy, there is no ln y, there is no, I mean, sin y, okay? We cannot take any functional value. Okay, so that is called a linear system. So the answer will be C. Why? Because you can see like here we have sin y, right? So this is a function. This is a function of this is a sine function of y, right? That's why this is not our answer.
Yep.
Here we have x squared. That means this contains a degree with 2. So this is also not a linear system. And here it is you can see x we have degree 1, 1 and 1. So this is a linear system. But for here we have degree with -1, and also we have degree with 2. That means this is also not a linear system. So our answer will be C, okay?
I'm not clear.
Okay, so we just need to see these two lines. Like the variable x, y, z, they must contain the degree with 1. That means their power will be 1. Only 1, okay? Nothing else. And there will be no functional term. Functional term means sin x, or they are multiplied xy, or ln y, okay? Or something else. So you see here, on the first answer, we have sin y here, right? So this is a functional term of, this is a sine function of y. That means this is not a linear system. And the second one, we have x to the power 2. But our formula tells us that we need only x to the power 1 or y to the power 1, right? So that's why this is
Oh, okay,
also,
okay, okay. I
yeah,
got it. I got it.
this is also not a linear system. The answer will be C. Okay. So let's see the next one. Assume that ABC are n by n matrix and K is scalar. Then which of the following inequalities is not true? Okay. So K is a scalar. That means some kind of number like 2 or 3. Okay. And ABC, they are n by n matrix. That means they are a square matrix. Okay. Then which of the following equation is not true? Answer will be AB not equal to B. Okay. Mm. Transpose matrix of C. Okay. A plus b square is equal plus. So I'm also not sure about this math because I asked Laoshi to explain this one, but she didn't. Okay. I mean, maybe she was too fast explaining this one, and I need to ask our Laoshi for help. Okay. So I'm skipping this one. Okay. I think this is very simple also, but I'm not sure like what is the real reason behind this. So I will explain this later on. Okay. So let's see the next one. If matrix A n by n is invertible, then here is the question. Sorry. Yeah. So okay, if matrix A n by n is invertible, then the following statement is not holds. Okay, invertible. Okay, number B. The reduced row echelon form of A may not be a identity matrix of n size. Invertible. Following statement. Okay, so let's see the invertible matrix. Conditions. Invertible matrix. So here is the condition. A invertible matrix is a square matrix that has an inverse. That means invertible matrix must be a square matrix. Okay. We say that a square matrix is invertible if and only if determinant is not equal to 0. So our question was, which of the following statement is not hold? Okay, that means which of the following statement is false maybe. So determinant is not equal to 0. So the first option here, x, if x is equal to 0, only have a trivial solution. Okay, let me show you the note of Laoshi. Maybe I explained that there. It was in lecture, I don't know the lecture, lecture 7. Invertible matrix determinant. need to be invertible. It must be a square matrix, and this linear system has only one solution if A is invertible. Okay. This was lecture 7, not lecture 6. A and B square matrix with the same size. A, B is equal to B is equal I. B is the inverse matrix of A. A is the inverse matrix of B. And okay. Inverse matrix. So you see here the condition. A is invertible and Ax equals 0 has only trivial solution. The RREF of A is is a identity matrix, and A is expressible as a product of elementary matrix. So our question was, okay, so assume that ABC they are square matrix and K is scalar. That means some number, okay, 2 or 3. Then which of the following inequalities is not true? Or sorry, the fourth one. If matrix A n by n is invertible, then the following statement is not false. That means which statement is false, I think. So the answer will be B. That means the reduced row echelon form of A may not be I to the power it may not be identity matrix. But here in our note, we can see that the RREF of A is identity matrix, right? So reduced row echelon form, that means RREF, right? You just take the first word R E and F, okay? So RREF. So our formula tells us that if this is invertible and if this is a square matrix, then the RREF of A will be a identity matrix of n size, right? So so this statement B, this is false, okay? And all other statement Ax equals 0 have only trivial solution. So you see here, Ax equals 0 has only trivial solution. And then A is expressible as a product of elementary matrix. A is expressible as a product of elementary matrix. So you see, all other conditions they are matching, but only this third condition, it is not matching here, right? That's why it not holds. That's why the answer will be B. So our time is over. We will join again, okay?